Ooh, sounds delicious. All right. So we're in section 9.2. We're ending up chapter 9. The material in 9.2 draws on some of the stuff that we learned in 8.1. So today we're going to be looking at confidence intervals when we're working with means. You're going to learn about t-distributions and t-values. Don't worry, they're not overly complicated. And we're going to also figure out the sample size needed for a certain margin of error and confidence level. Then after that, after we do this lesson, then we will go over the lab, because lab 5 is our last lab. We will go over that as well. And it should be pretty quick because it is using some of the tools we already have, just adding one little piece to it, using it for what we're doing right now. So that's tonight. Because you already know what a confidence interval is, it won't take us quite as much time because I don't have to talk about what is a confidence interval. Why are we finding it? We're doing the same thing. We're just doing it with means. And so we'll get to that. And I need my iPad. Let us hope I don't do anything weird with the iPad. There we go. All right. So when we are dealing with means, our point estimate would be our X bar. It would be our sample mean. So we use, obviously we use X bar when we don't have the population mean or when we're dealing with a sample. So what we're going to be doing with our confidence interval here is we're going to be estimating the population mean when we don't have it. So that's what we're doing today. So, all right. So I have all of these pennies that were minted after 1982. They're made from 97.5% zinc and 2.5% copper. We weighed this sample of 17 randomly selected pennies, and we're going to estimate the population mean. So all I'm going to do is find the sample mean. So I just took all of them, I divided by 17, and I'm estimating based on this sample that our population mean is 2.464. In this case, we will call it a point estimate because it's just an estimate based on just the sample that we have. So just find the mean. Remember, sample mean is calculated exactly how we calculate population mean. You just use X bar instead of mu. And always round to one more decimal than your raw data was. So if my raw data had 2 decimal places, which this did, we'll round to 3. So this hopefully is not completely new information, just a little bit different wording, calling it a point estimate. So a t-distribution. So we use a t-distribution. We use it mostly when we have smaller sample sizes. So a t-distribution is kind of like a z-score, yet it is a little bit different because we use n-1 degrees of freedom. Don't worry yet what that means. So we're going to calculate this exactly how we calculate a z-score. So you're going to take your sample mean, subtract the population mean, then divide by this new standard deviation. This is going to give us our t-value. It's going to be called a test statistic later on, but this is how we're going to get our t-value. Don't worry about it right now. Once we're doing it with math, it'll make more sense. A t-distribution is a little bit different than a z-distribution, than a normal distribution, slightly different, but it is still basically normal. It's just mostly used with smaller sample sizes. In this class, we're just going to use t-values every single time we use mean. If I'm constructing a confidence interval with mean, I'm going to use t-values. So you don't have to try to figure out if the sample size is big enough or anything like that. Anytime you are looking for a mean, using the confidence interval for mean, use a t-value. All right. So I'm going to draw a histogram for both t-values and z-values. So we're going to look at sample sizes of 5, 50, and we have sample sizes of 5, mean is 50, and standard deviation is 10. And I'm going to show you what the histograms look like for both of them. So here's my histogram for Z, and it's mostly normal, but I mean, it's not It's not as beautiful as I would like it. Here's my histogram for T. Now notice that my middle looks really great. My middle looks really great, but my tails are longer. So look back at Z. We don't have a whole lot out there in the tails. With T, we've got a little bit more out in the tails, but the middle part looks more bell-shaped, but my tails are longer. Don't worry, I'm not going to be requiring you to make histograms. So the histogram is symmetric and bell-shaped. Our center of distribution is at 0. Almost everything is between -3 and 3. So it follows basically a standard normal distribution. My t-value, it's symmetric and bell-shaped. My center is at 0, but it has longer tails. It is more dispersed. So it doesn't necessarily follow the normal distribution. It is spread out more, but it looks fairly normal. And we have this distribution looks a little bit different because we are using sample data. We're using the sample standard deviation instead of the population standard deviation. So I don't know the population standard deviation in most cases. Therefore, we have to use the sample and we use T. So I am not going to ask you at all to describe the difference between a T distribution and a Z distribution. You are not going to be asked that. So don't worry about memorizing that. But here's the difference. Our T distribution is different for different degrees of freedom. So think of, it's a little more complicated than this, but just think of degrees of freedom as sample size. We're not going to get any more complicated than that. So with our degrees of freedom, we're going to think of sample size. Our T distribution centered at 0. The area under the curve is 1, just like it is with a regular normal curve. 50% is below the 0, 50 is above, and it increases as we get bigger and smaller without bound. We go to -infinity, infinity. We get really close to 0, but we don't reach there. The difference lies here. The area in the tails of the T distribution is a little greater than the standard normal distribution. So as our sample size gets bigger, our density curve of T is going to get closer and closer to the standard normal density curve. So remember when we were dealing with X bar, and we talked about how once we get a sample size greater than 30, then our sampling distribution is normal. That's what happens here. Once our sample size gets greater than 30, our curve, our T distribution, looks basically like a normal curve. It's almost exactly like a normal curve. So 30 or greater is going to give you basically a normal curve with your T distribution, but we're still going to use T-scores even when we hit 30. So here's what it looks like. So the normal curve is the blue one with a sample size of 5. Notice how, I'm going to get a highlighter. Notice how I go, that's not a highlighter. Notice how I am like wider here. I want a better color. I'm wider here at the bottom. So it more gradually goes down towards 0. But then with 15, I'm really close to that normal curve. If I got to 30, it would basically be right on top of that normal curve. So that's just the shape part. So the T values, we get these T values just like we get our Z scores. We use a table. We also have something in the calculator, which I'll show you in a little bit. So T sub alpha is the T value that is, I just lost it. So to the right is alpha. So we did this with Z. So if I was looking at a 95, well, that's weird. So we talked about this on Tuesday. If I have a 95% confidence level, 1 minus 95 or 1 minus 0.95 or 0.05, that would be my alpha. And because a confidence interval, you wish you had different colored pens. I know, see, you should get some for your next term in college. Get some colored pens. So If I'm looking for a confidence interval, once again, we're going to do alpha divided by 2, which would be 0.025. So the alpha is the same. The alpha is the area outside of my center, whatever. Okay. We're going to use t value under the t distribution. We're going to look for 0.2 to the right of the t, 0.2. We're going to look at 10 degrees of freedom. So our alpha is 0.2. We're going to look at 10 degrees of freedom. Let's take a look at our t table. First, let me show you the t table you have. So the one you have access to, the first page is our z table. If you scroll down, we have this lovely t table. So with the t table, we're looking at the area in the right tail. A little bit different than z-scores. I'm going to make this bigger. So 0.2 is right here. 10 degrees of freedom is right here. 0.879. So you just go to whatever your area in the right tail is, and then you go down to however many degrees of freedom. I'm going to go back here. So once again, this one looks a little bit different. So I'm looking at 0.2, go down to 10 degrees of freedom. And I have this right here. That's a terrible color highlighter. Right there. So our t value with 0.2 is my alpha, and 10 degrees of freedom is 0.879. Questions on finding the t value? I will show you soon how to find the t value using your calculator. Don't worry, it's coming up. But I want you to be able to use the t table also, because it is kind of cool. And I'm weird. I like weird things like that. All right. Okay, so I would like you to find the t value so that the area under the t distribution to the right of the t value is 0.05. We have 15 degrees of freedom. I'm going to go back to the t value here. So we're looking for 0.05 and 15 degrees of freedom. This is the column we want. Down here, 1.753. So we haven't divided our alpha in half yet. We're just practicing looking at our table. So with 0.05 in the right tail, 15 degrees of freedom, we're at 1.753. All right. All right, so let's talk about our confidence interval for mu. So we need to come from a simple random sample or a randomized experiment. Our sample size needs to be less than 5% of the population. Either our population needs to be normally distributed, or the sample size is large. This means that my sample, 10 is good, sample has to be greater than or equal to 30. So if the population isn't normal, our sample size needs to be greater than or equal to 30. Here's what our confidence interval looks like. It's the same thing we did when we were doing with the proportion, when we were doing proportions. However, instead of a z-score, we're using a t value. And instead of that square root of p times 1 minus p, we're using the new standard deviation for means. So I'm taking the t value, except for, take a look here. When you are finding your t value, use n minus 1 degrees of freedom. This means take your sample size, subtract 1, and use that for your degrees of freedom. And you are using the alpha divided by 2. So if I was doing a 95% confidence interval, I would use 0.025 to look at my t table. So for example, let's say I took a sample, I'm going to write it up here. I took a sample of 12. And I'm looking for, where did that go? I'm using a sample of 12, and I'm looking for a 95% confidence interval. Okay, so I subtract 95.95 from 1, get 0.05. 0.05 divided by 2, 0.025. This is the column I'm going to look at. So I'm going to look at the column 0.025. And because my sample size is 12, I'm going to get the z-score from n minus 1 degrees of freedom. So I'm going to go down here to 11. So my t-value would be 2.201. This t-value is also called a critical value. It's the same thing we did with z. It's called a critical value, 2.201. So make sure to subtract 1 from your sample size. I'm going to put an arrow here. Critical value.
Sorry, I'm
Yes.
super confused. We're
Okay.
the n minus 1.
What about it?
So why am I subtracting 1? I'm sorry.
Because we're using sample data.
Uh-huh.
You remember when we were doing sample standard deviation, we divided by n minus 1 because of the
Okay.
variation in samples. This is the same thing.
Okay, gotcha. Perfect. Thank you.
You're welcome. Yeah, because there's so much variation in samples. We're kind of like, I'm erring on the side of caution here. It'll make my t-value just slightly bigger just to take that into consideration. That was a really good question, Alice. Thank you. So yeah, it's because of the variation of samples, we subtract 1 from the sample size before finding our t-value. Thank you so much. All right. So we're going to construct a confidence interval here, and I'm going to do it mathily, and then the next page has all the math, but I'm going to do the math for you. So this sample, thankfully, I don't have to put all of this in my calculator, but I could. We have a standard deviation of 0.02, and I have an X bar of 2.464. There are 2, 4, 6, 8, 10, 12, 14, 16. There are 17. My N equals 17. I'm looking for a 99% confidence interval. So to get my alpha, I'm going to do 0.99, 1 minus 0.99, which is 0.01, divide that in half. So I'm going to look in the column that corresponds with 0.005, and I'm going to look at 16 because that's n minus 1. So let's go get that value. So 0.005, I'm way over here. And I'm going to go all the way down here to 16. So I have 2.921. So my t sub alpha divided by 2 is, I just lost it, 2.921. Writing it down, just give me a second here. All right, go back here. Okay, so I have my critical value. That's what that is. Critical value. So what I'm going to have is I'm going to have X bar plus or minus my margin of error. So just like when we were using z-scores, it's the critical value times the standard deviation. So my margin of error is going to look like this. 2.921 times, I'm going to use parentheses, my standard deviation divided by the square root of my sample size. Here you're using the sample size. Don't do n minus 1 for the standard deviation. I'm going to put this in my calculator. Woo! Just had lots of weird things happen over here. So that's approximately 0.014. All right. So my confidence interval is going to be 2.464 plus or minus 0.014. I'm going to math that out because if I was writing it in interval notation, 2.478, then 2.464 minus, and it's got to be 2.45 because rounding it, I'm going to end up that 9 rounds up anyway. All right. Okay, I'm glad. Oh, I'm so glad that this is clarifying it for you. Yay, good. So this is helpful then. Good, 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 good. It could be a symptom. It could be a symptom. You never know. All right, good. So this is my confidence interval. So the way that I would interpret this is I would say, I am 99% confident that the actual mean weight of pennies minted after 1982 is between 2.45 and 2.478 grams. This is how I would interpret this. And you're going to get a sentence written on the thing in a second. Right, here's the math they used. They have the same thing I do. And here's what, look at that. That's almost exactly my wording. So this is their math, and that is exactly like my math. It's just typed in there. So if you printed the PowerPoints, you have that there nice and pretty. I just feel like better retention when I talk you through it rather than show you a big screen full of a wall of math. Do you all agree, or do you want me to just show you walls of math? I want to make sure that I'm doing what's best for you.
No, please keep explaining.
Okay, no walls of math.
No walls of math, please.
Okay, the walls of math are fine after I've already explained it, but I'm glad. Okay, good, because it just seems personally, I would want somebody walking me through it rather than just say, here's how you do it. Because if you wanted this, you would just read the textbook, which is really dry reading. All right, so we're going to use the calculator now. We're going to do the same thing, but we're going to use the calculator. So I can calculate the sample mean and the sample standard deviation. I can use the calculator and use one variable statistics. So if you want to do it by hand, use your one variable statistics. You might have to go back to probably week 2 to remember all of that. Actually, I'm just going to put it into my calculator in case you forgot, and I'll show you that. And then I'm going to show you how to do this with your calculator, because your calculator is an amazing, amazing thing. It's my best friend. Not really. Well, maybe. Okay. So I'm going to go into stats. Maybe. Come on, calculator. You'd think, being my best friend, you would actually work for me. It's been really slow lately. I don't know what the deal is. We might use the calculator. I'm wondering if I can give permission for my other computer to share, but I don't think it's going to let me log into the calculator. Okay. I'm going to refresh the calculator. We'll see what happens. Using technology to use exactly. Okay, I might just have to walk y'all through stuff because my calculator is not going to do its job. I might just have to walk y'all through it. Let's just hope. Okay, make me log in again. I don't care. I will log in again. I'm actually getting a new MacBook on Tuesday. So next week's class, hopefully, will go like super smooth and everything will run better. They gave me this MacBook when I started there 5 years ago. And I mean, I don't think 5 years is that old, but apparently they do. So the school's giving me a new one on Tuesday. Okay, let's see. Make it bigger. Ooh, make it smaller. Hit the stat button. Let's see what happens. There we go. Okay, so stat edit. I'm going to go up and I'm going to clear enter to get rid of that. I'm just going to put these values in. Feel free to put them in along with me, unless you've already started doing that. 35.7, 37.2, 4.1. Uh-oh. 37. Almost at the bottom and I start making mistakes. All right. I'll give you all a second to get the rest of those numbers in there. All right. Okay, now we're just going to do one of our stats first. Stat, go over to calc. We want the first option. I do not want a frequency list. I'm going to delete that out. This L1 is the list I'm looking at. Hit calculate. So my X bar here, my X bar is 36.8. And my standard deviation, my sample standard deviation, remember you're using sample standard deviation. So I have, wait, I'm going to do 917 just because of rounding. So my sample standard deviation is 2.917. My X bar is 36.8. Now that I have those values, if I wanted to calculate this by hand, I could. So I'm going to, just to help you out, just because we haven't done this enough, we're going to find our T value. So we have 16 different owners. And we're looking for a 95% confidence interval. So once again, we're going to look at 0.025. And I'm going to look for 15 degrees of freedom, because remember, it's n-1. So 15 degrees of freedom and 0.025. So my table is right here, 0.025. Go down to 15. So my T value, T sub alpha divided by 2 is, I lost it again, 15, 0.025, 2.131. All right. So I'm not going to hand calculate this one because I just did one for you. I'm going to show you what to do with the calculator. I didn't technically need to find these independently. I just wanted to remind you how to do it. So these will be found with the calculator. So I'm going to go back over to the calculator. We are going to use, I wish that this thing right here would go away. There we go. We're going to use, we're going to use T interval. So I'm going to go to stats, go over to tests and use T interval. So here we are. So once again, hit stat. I'm going to arrow over so that tests is highlighted. And T interval is number 8. Okay. The cool thing here, if you put your data into your L1, you can use the data and tell us where it is. It will do all of the math for you. If you are given stats, if they give you a mean and a standard deviation, then you will go over to stats right here. It will take care of your degrees of freedom and all of that stuff for you. You don't have to worry about that. I'm going to go to data because that's what we have. Go down here. We're doing 95%. So I'm going to leave that there and hit calculate. Bam. It doesn't give us a T value because it doesn't need to. It just gives us our confidence interval. So our confidence interval goes from 35.246 to 38.354. And it gives us our mean and our standard deviation. You're understanding the schmanciness? Good. I love that. These are the fanciest, schmanciest calculators. It's funny, my high school students go, you don't say fancy schmancy to your college students, do you? And I'm like, well, of course I do. Why wouldn't I? Why wouldn't I say it? They think I'm not weird for everybody. Strange. All right. So what were we looking at? Miles per gallon in a Ford Focus. So if I was going to give this a conclusion, I would say we are 95% confident that the true mean miles per gallon of a Ford Focus automobile is in between 35.246 and 38.354 miles per gallon. So that's how we would answer this question for the conclusion. Questions before I move on? Okay. Y'all want to know how to find a t-value if without using the table? I figured you just might. Here we go. So you know how we use inverse norm to find z-scores or to find data values? If you go to second vars, inverse t right here, inverse t right here, will you give the area to the right, so 0.025, what we just used. Make sure you subtract 1 from your degrees of freedom. So I had 16 car owners, so I'm going to use 15 degrees of freedom. So make sure you subtract that 1. If you don't, you're going to get the wrong value. So I'm going to put that in there and bam, it's going to give you a negative. No big deal. You want the positive. Just use the positive. You could have put 0.975. Doesn't matter, but just remember you want a positive t value. Just throw that negative out the window. So just use inverse t. Don't forget to subtract 1 from your degrees of freedom. Tables can be annoying if you're in a hurry, but I do find a little bit of elegance from them. But I totally understand others who don't. I'm just, as I said, I'm weird. So there you go. All right. Okay. So I know y'all were like, how do I find the sample size if I know the margin of error and the confidence level? How do I do that? I'm so glad you asked. So our problem with this formula, we had a problem with the other one as well. The problem here is that you need the sample size in order to find your t-value. Therefore, we have to use the z critical value to find the sample size. It makes sense. So you just take the z times the standard deviation, divide by your margin of error, and then square everything. Same with our proportions, round up to the next highest whole number. So we're going to do some examples here. Back to pennies. We want to know how large of a sample size do we need if we want to go within 0.005 grams, 99% confidence, and we are assuming that the standard deviation is 0.02. We don't have a sample to find the standard deviation of, so we have to use whatever standard deviation they give us. They're going to give one to you. So I need to get my z-score for my 99% confidence interval. So remember, 1 minus 0.99 is 0.001, 0.01. I'm giving them extra. Woo! 0.01, 0.01 divided by 2, 0.005. All right. So this is what we're going to use for our critical value, or we can just use our table right here because I have that critical value, bottom of my Z table. Come on, scroll. There we go. 99% confidence interval, 2.575. So that's my Z. I'm writing it down. Since it's already there, or you can use your inverse norm, but it gave it to me, 2.575. All right. So I have my Z-score. So my N is going to equal 2.575 times 0.02. My margin of error, 0.005, then square it. If you're good with your calculator, put it all in at once. Be careful with parentheses. Something's off here, I think. Did they get the number I did? Yeah, they did. Okay. Sorry. We can't find T here. We can't use T. We have to use Z because we don't have a sample size. So we have to use Z. Yeah. Just because we have no sample size, we have to use the Z. All right. So I got in my calculator 106.09. Wow, that's really ugly. 106. So we would have to round that to, so our N would have to be 107. Always round up. So I would need a sample size of 107 to get it within 0.005 grams and a 99% confidence interval. Questions? All right. Here's the wall of math. They did the same thing I did. So there's your wall of math. I love it when my math matches the wall of math. Okay. All right. So I would like you to try to find your sample size with a 95% confidence interval within 0.5 miles per gallon. I'll get you that, get you the Z score. Our Z score is 1.96. And then did they give us? We need their standard deviation. What was that standard deviation? So rude of them. Miles per gallon. Where were we? Our standard deviation, 2.917. Is that what we're using? Oops. Didn't give it to us. So my standard deviation, woo. My S, 2.917. So use that for the standard deviation. So go ahead and calculate your. I'm going to work quietly behind you. How we do? I mean, it's always possible I made errors too if you didn't get the same thing as me. Did we get the same thing I did? Questions?
Yes. Can you hold my hand when we take our test?
No, the 0.5 is my margin of error. I don't need to divide it by 2. It's a margin of error. Yeah. It's not the confidence level. I know. Did everybody else get the question correct? Did we get these numbers? Doing okay? Okay, good. Yep, holding both hands. I don't know how I'm supposed to do that through a computer, but we'll figure it out. Well, I need to grow some more hands. All right. So I think is that it? Okay, this is just kind of a, because I know y'all want this and you'll be here. So section 9.1, This is what the problems look like for 9.1 when you're using the z-scores and that lovely p times 1 minus p thing for your standard deviation. A problem would look like this. Obtain a 90% confidence interval for the proportion. You will see the word proportion in there. You're going to see the word proportion if you're using the stuff from 9.1. In 9.2, you are going to see the word mean. They will, or average. If you see the word proportion, use the 9.1 stuff. And this will be use the z sub alpha divided by 2 times square root of p times 1 minus p. This is your p hat divided by n. So this is your margin of error for that. Oh, wait, instead of that, I'm going to do this. P hat plus or minus. All right. If on the mean, when you see mean in your question, you will use t sub alpha divided by 2 times s divided by square root of n. And this will be x bar plus or minus. So that's the difference between the two sections. You'll see proportion in one of them, use that. See mean in the other, use that. Give you a second to write that down, and then I will give you the other one. All right. So sample sizes. Sample sizes. A second here. I just lost my train real quick. My train went south. Things like that happen occasionally. Okay. So you will see things like let me see. If she wants to obtain within 3 percentage points, usually it'll say something like within 3 percentage points. And it might say something like there was a previous survey, might say something about a previous survey or something like that. But your margin of error will be listed as within a certain number of percentage points. Then you will use this formula. That's the formula that you are going to use. Oh, did I need to go back, Quentin? You want me to go back to the other screen? Okay. Okay, let me know when I can move on. Okay. So with the mean, when you're looking for a sample size, it'll say estimate the mean, and it will probably give you a standard deviation, and it's going to give you your margin of error is going to be in like miles or degrees or whatever. It's going to actually have units rather than percentage points. And then you'll use the formula. That's really ugly z sub alpha divided by 2. Hopefully you guys are okay with that. Then you use that formula. All right, I'm going to let you make sure you can get this written. This is my last slide, and then we're going to do the lab. All right, does anybody need more time? All right, so this is the end of the PowerPoint. If you have questions specifically about this lesson, I can answer them now, and then we'll go on to the lab. Does anyone have questions?
I do. It's more related, I think, to the upcoming test.
Okay.
Um, so are the questions that we're going through now going to be similar to the ones on the test, or are they just going to be? I think that's what I struggled with on the last test was that I gone over homework and stuff we studied, and then I got to the test and I was like, it just didn't make sense. So is there anything else that I can like write down to help me if they're going to be a little bit different? Like you said, these words right here for 9.1 and 9.2 are super helpful.
Those words will
But
be there. Those are, I mean, that's how the questions will, I mean, you will see those words in the
okay,
questions.
okay,
So
perfect.
that's why, I mean, that's like specifically why I give them, because it's like, these are keywords I want you to look for.
Okay,
So yeah,
great. Thank you.
you're welcome. Okay. Anything else? All right. I'm going to get off of the PowerPoint and I'm going to go to the lab. Okay. So just use your continuous data from previous labs. So just use that continuous data. You know, if you want to, just because, hey, why not? You could always use your data from your final project. So if you have some continuous data from your final project and you want to throw it in there, just why not? Feel free. It's totally up to you. So we're going to once again use the data analysis tool. So it should still be installed on your Excel. If it's not, go back to the Lab 2 video and get the instructions on that. But it should still be there because it doesn't just go away. So I'm going to use this data analysis tool. So I'm going to pick that up. Once again, we're going to go to exactly where we were before. I'm going to descriptive statistics. So the data analysis tool, click on descriptive statistics, and then click OK. Okay, we've seen this before. Now my input range is going to be all of these lovely things that I have here. There's a whole heck of a lot of them because I'm crazy. Okay, I have 139 of them. Okay, so all I did was just highlight them so that they would end up in there. My output range, I'm going to try to put them in this box up here. I want them to end up in this box. That's my output range. Couple of things you're going to click. We do want summary statistics. The thing that we need now, though, is I want confidence level for mean. This is the new thing. I want confidence level for mean. You can choose whatever confidence level you want. You could make it 95. You could make it 99. You could make it 92.3. I don't care, 88, whatever confidence level you want, choose something. I'm just going to leave it at 95 because it's there. And why not? And it is going to put everything in here nice and lovely, just like it did before, and gives us all of these numbers. My mean is right here. So the standard error, this right here, the standard error, this is that new standard deviation. It calculates that for you. It's the actual standard deviation. The numbers we are looking for is right here. So this, where it says confidence level 95, this is your margin of error. So once again, I want you to use your Excel tools. So I click equal and then click on this number and hit enter. The mean it gives me equal. Click on the mean and hit enter. Then for lower bound, I'm going to take the mean and subtract the margin of error. I'm going to do 11 or equals this minus this, enter, and it's going to give me my lower bound. For my upper bound, I'm going to take the mean and add the margin of error. So equals mean plus this one right here and hit enter. So that gives me my confidence interval. So what's happening down here with interpreting your results is it is just scaffolding. It's like baby stepping you through it. So what am I estimating in the context of the problem? I am estimating the population mean strength of earthquakes in the world. That's what I'm estimating. How confident am I that the population means in my interval? Because my confidence level is 95%, I am 95% confident because that's what I chose for my confidence level. The final one Interpret my confidence interval. This is where you write your conclusion. I'm 95% confident that the actual mean earthquake strength in the world is between 6.86 and 7.23 on the Richter scale. So that's the bottom is just you writing your conclusion. That's it. That's the whole lab. Questions on the lab? So if you already have your continuous data, this lab could literally take you 5 minutes and get you your 10 points like that. Maybe a little bit more for, little error here and there, but literally 5 minutes, 10 max. All right, that's all I have for you today. Any questions for on camera? Any more questions for on camera? Or on video, whatever, on recording? I don't know what the words are. All right. I'm going to stop recording.